Good afternoon. This is Eric Miscoll with EMSNOW. I'm here at Apex in San Diego 2020. And once again, I found Michael Ford to come with Aegis to come in and share his insights with us. Always good to catch up with you, by the way.
Yeah, it's great to be here. Thanks.
So we've been chatting a bit about kind of where to go in our discussion. And what I suggest is, we were talking here just before about what's the end state here. So you think Industry 4.0, what is that end state that we're all aspiring to, gathering data for and all that? And you told me you have the answer. So no pressure, but here we go.
I'm the marketing guy. I always have the answer.
Or at least you'll make it up.
Oh, I wouldn't say that. So I think what we're after ultimately is I'll call it a black box, where the factory is an engine which is programmable to make whatever product we want whenever we want it, at optimum efficiency, such that we can satisfy a local market where products are being demanded at random. So there's no stock between that black box factory and the customer. But it simply makes and delivers what it has to. So we take out all the waste, we take out all of the depreciation costs, all of the warehousing costs, the storage costs. The challenge then is to, within that box, to be able to have a factory. Now, it doesn't need to be lights out, because people sometimes refer to this as lights out, which implies there are zero fixed costs of labor. But actually, labor is a good thing. Labor is really flexible asset, and if used properly, can actually yield a lot of creativity and flexibility, making that factory quite agile. It's then down to the use of automation. Now, the automation that we're talking about is no real difference from what we have today, other than we can automate the layer of automation. So instead of the machine just being fed a program, it needs to be part of an intelligent infrastructure that is designed to immediately react to customer demand, to configure and organize itself in an optimized way that is able then to produce that product for that customer. So it's an automated manufacturing environment made up of automated machines and processes.
And so that's very good. Is everyone involved in Industry 4.0 and traveling this journey, and we see them all around us, all clear on that's the end? Is there a general agreement that that's the end state that's desired?
Not at all, because people have different priorities and goals which follow their customers' need today, which is what they have to do, yeah? And so I think there is an evolution of the thinking about how that's going to happen. And the end goal, I expect, is going to be having this factory unit which is going to be able to deliver whatever we want, whenever we want. Right. And the real challenge to achieve that is, how do we make that functionally possible, where we have the degree of automation that we need in such a complex area as SMT manufacturing, for example, and mechanical assembly as well. How on earth can we make that happen automatically? How, to see everything, to understand everything, to know the consequences of everything we do, so that we can get rid of that last ounce of waste from that operation. And that's the challenge.
Right. So there's a lot of data being gathered in this industry, a lot of data. In a lot of ways, and I was saying before, some of it's probably noise, at least initially, but so it's sorting through that, figuring that out, and making sense of it, right? There's data, there's analysis, there's insight, and there's action. Right? It's kind of how data is just data until you move forward in some way, and that takes intelligence, insight, consideration to get there, right? Yeah. How do you see that evolving?
There are really two camps of thinking in this area. The first is the traditional approach, where we have 30 years or more of manufacturing for circuit boards under our belt, using automated processes. And we know the metrics that drive manufacturing improvement. We know how to do that. The limitation that we've always had is that we cannot see beyond our human eyes. And so we need to find a mechanism to bring the data to us in a way that we can easily understand it and recognize and use that information with our built-in knowledge and experience to then action decisions much more accurately and quickly that affect a greater area of the factory. And this is what we're doing, for example, with the MES platform, the IIoT-driven platform. So we're delivering that information in a way that helps to make those decisions. Now, on the other level, there is a greater detail of information than anybody would ever think they would need, where you are able now to pick up some really exquisite bits of data, like, temperatures, vibrations, voltages, patterns of operation, and these kind of things that, you would look at the data and think, well, yeah, so what? However, you can, using analytics, let's just say on a motor, if you do an analytics of the current that the motor is drawing and the vibration that is caused, you can actually very accurately predict the life status of that motor. And you understand what it's capable of doing, how long it's going to last, and you get an alert about some impending problem before anything happens. So there are thousands, literally thousands of cases where such logic can be applied. And so we're getting a whole new level of data now where it's not intended for people. It's intended for machines like computers to learn and to be able to see and use that data to predict patterns and identify, I call them complex anomalies, where it's not just like something happens and it causes a problem. It's like something happens and something else happens and something else happens, which in isolation are fine, but you put them together and you've got the risk of a defect or a machine stop or something like that. And it's recognizing these complex anomalies that enable then the data analysis to show something to the people that they've never ever been able to see before. And so that's additional information with which they can make decisions.
Yeah. And we're going to have to wrap here, so I could go on for hours with you, but that's where the role of AI comes in, right?
The true AI is
is
the ability for an intelligence where instead of simply following parameters and following some kind of algorithm, it's able to develop and adopt new algorithms by itself, by recognizing and understanding what is a good outcome and what is not. So the training of what is good and what is not is the key thing there. Otherwise you get terminators. Yeah. But it really is that ability to find patterns which previously have not been requested. Now there are companies that we know very well, for example IBM's Watson, they have this kind of platform. What if? What if an AI like that was actually that capable? You would have a baby in charge of a factory initially, and so that would be useless. But after a while, it would learn.
But in a quick while too. Right?
In a quick while, in human terms, for sure. We're talking about minutes and hours and maybe days rather than years. And that could, again, follow the same process of finding patterns, bringing to us potential solutions, aiding our built-in decision-making abilities. But at some stage, maybe we trust it enough to run our box of tricks that's making the product in time for our customers and managing all of the dependent processes within that box.
Very good. I must say, I always enjoy speaking to you. I always learn when I speak to you, and you do a great service to the industry by
thank you very much.
Sitting in your place in England and thinking long and hard about this. Then it's probably healthy, right? So, but thank you again, and we'll catch up again this year at another show.
Yeah, thanks very much.
Thank you, sir.